Struvite crystallization. In this PowerPoint, we will go over why we need it, what is struvite, how it is produced, as well as some of the problems associated with struvite. With declining phosphate reserves and stricter regulations regarding wastewater discharge, the need for phosphorus removal and recovery is growing. Crystallization is a viable option since phosphorus would not only be removed from the waste stream, but can also be recovered as struvite to be used as fertilizer. Struvite, also known as magnesium ammonium phosphate hexahydrate, or MAP for short, is a white/whitish yellow or even sometimes a whitish brown chemical compound which can be formed by the controlled addition of magnesium to the waste stream that contains nitrogen in the form of ammonium or phosphorus at the end of the manure treatment system. Now, there are a couple of ways struvite can be produced. The first way is a selective ion exchange. The second way is the crystals can be precipitated out in either a stirred reactor, a fluidized bed, or an air agitated reactor. Of the processes that I just listed above, the fluidized bed reactors or the air agitated reactors are the two most commonly used processes for crystallizing struvite from wastewater. These reactors normally consist of a vertical column with a seed material inside upon which the struvite precipitates. The process usually makes use of a chemical additive to reach a desired magnesium, phosphorus, nitrogen molecular ratio. After these adjustments, the struvite particles can precipitate spontaneously, and growth in an aerated reactor will occur due to the interaction of the particles. The fluidization of the particle is achieved through one of two ways: the liquid flow from the feed entering the reactor at the bottom of the column, or the upflow circulation of air that keeps the growing particles from settling down. With the liquid, it would enter through the bottom and the heavier particles will settle to the bottom and then are extracted out of the bottom and sent on their way. With the air reactor, the smaller particles are spun to the top and pushed out through there, and they are extracted that way. There are a few problems with struvite. The first one is if the struvite particles are too small, they will be flushed out and you will lose them. If they are too big or not moving fast enough, they will clump up and clog up pumps and pipes, costing money and downtime. Of the method that I just listed above with the fluidization bed reactor, that is the most expensive operation because it must be continuously in a fluid state, requiring a higher operating cost. Crystallization of struvite crystals can be developed in two chemical stages: nucleation and crystal growth. However, there are multiple factors that affect the amount of phosphorus that can be recovered from this process. pH, supersaturation, the temperature, the mixing energy, the molecular ratios, and the presence of interfering ions. The optimal pH is dependent on the composition of the wastewater. Different wastewater streams will have different values for the optimal pH. It mostly depends on the calcium, magnesium, the phosphate, and the NH4 ratio. For the temperature, it needs to be between 15 and 25 degrees Celsius to obtain the most amount of phosphorus possible. So some key points to take away from this PowerPoint are that no two batches of crystals will be the same. It will depend on the pH, the weather elements that the manure was exposed to, how far away the reactor is from where the manure was obtained, the pH, as well as there are multiple processes that can be used in order for the crystallization. But the two most common are the fluidized bed reactors or the air agitated reactors. These processes are currently in place at some wastewater treatment plants. The reason we have them there is because there's more of a consistent, steady supply of waste that can be used for crystallization, and because they have a problem with it crystallizing in the pipes. The reason we don't do very much of this on hog farms is because with hog farms, the manure is stored under the hog house for a brief period of time and then pumped into the lagoon / concrete pit. You can get different pH readings and different amounts of magnesium that are needed to treat each batch, adding in higher cost, as well as the location of the reactor will have some play as to how much phosphorus you can get based on where it is at on the farm, if it is close or if it is further away from the hog house. Thank you for watching this video.